Sedimentary rocks are formed when sediments are compacted and cemented together. We'll go over that process in a minute, but these are some examples of sedimentary rock. You can see the actual grains in there, and they are stuck together with a mineral cement, like a glue that sticks all those little sediments and particles together. The other feature of sedimentary rocks is that they tend to have layers in them. So they're not that easy to see in this particular sample, but also the fact that they have fossils in them, which on this specimen you can see this is not a feather, but it looks feathery. And some shell in the back. So where do the sediments come from that form these sedimentary rock? Well, they come from other rocks, even other sedimentary rocks that get broken down and worn down like this over time. The bits get broken off by various ways, and then the cycle starts all over again. So you can see that sediment there that can easily be broken off. So sedimentary rocks are often quite soft as well. You wouldn't want them thrown at your head, but they are still quite soft compared to the other types of rocks. Sedimentary rock formation always starts with rocks. Those rocks have to get broken down. You can see there are 3 different ways that they are broken down. They get broken down into small sediments. You can see those down the bottom. Those sediments are usually washed by a process of erosion. So after the weathering happens, the breaking down, the moving of those sediments is called erosion. And that's usually to do with water, can be to do with wind, can get moved around by wind and other ways, but mostly due to water action. And they are carried down and deposited at the bottom of lakes and rivers when the water slows down and stops moving. So the sediments drop down to the bottom and build up in layers over time, and you can see the different layers there in that picture. When a lot of layers build up, this is a close-up version of what's happening inside, those little sediments get squashed close together by the weight of all those layers above. So it's tons and tons of pressure pushing them together and squeezing all the space out from between them, so they're quite close together. But it's still not enough to make them into a rock. They can still fall apart. So what is needed is the cementation process, or the gluing together. So when rain comes or water comes down through those layers, it carries dissolved minerals, just like when you dissolve sugar or salt in warm water, or you can in cold water too. You can't see it, but the minerals are still in there. So when the water evaporates, the crystals are left behind, and those crystals act like a kind of glue that stick the little sediments together and cement them together, and this makes them hard. Not the very hardest of rocks, like I showed you, but they are hard enough to be classified as a rock. And you can see in the last picture a representation of the crystals there that have grown out of the solution and stuck those grains or those sediments together. Igneous rocks are rocks that have formed from the cooling of magma or lava. So they either form underground or above ground. If they form underground, they're called intrusive igneous rocks. And if they form underground, the magma will cool slowly, which gives the crystals time to grow bigger. So you're more likely to end up with specimens like this, where you can see the actual mineral crystals in them. So you can see a black mineral, an orangey mineral, and a whitish mineral in there too. And this is a very common rock called granite from around these parts down Wilson's Promontory. So this one is likely to also be an intrusive rock because the crystals are quite big, though they're similar in colour, white and grey. This is a nicely weathered igneous rock, very smooth. And the crystals in this one seem to be very small, so that's quite different. So the essential thing is the time that they take to grow because the magma cools slowly. However, when something like a volcano erupts, the lava, that comes out of the volcano forms what we call extrusive rocks. Now these rocks can be different types, but some of the ways that you can tell them are that they can be quite like honeycomb or have holes in them like this, and that's from the gas from the volcano that gets trapped in the rock when it solidifies so quickly, like snap freezes, so the gas bubbles get trapped in there. So this is quite a common extrusive rock, and because it cools so quickly, you can't see crystals in it. It just all looks a browny kind of colour. This is the same kind of rock from Iceland, but it's been weathered. It was on the beach, so it's been weathered significantly. So even though it's got holes in it, it looks like a smooth pebble, but it's still an extrusive igneous rock. This is another extrusive igneous rock, and it's a really amazing kind of rock. It's called pumice, and it gets shot out of a volcano. Well, it's a product of lava. So this is what's so special about it. You can't tell through the camera that it was very light, so I thought I would show you by showing you that it actually floats. So even though this one has holes in it, it doesn't float. And the pumice, you can find it on the beach, often in areas of volcanoes, because it will float across the oceans. So remember, extrusive igneous rocks are formed from lava, and they have very small crystals because they cool very, very quickly, and sometimes, but not always, they will have gas bubbles in them as well. Lastly, we have metamorphic rocks, and metamorphic rocks are formed deep underground because they are formed as a result of heat and pressure. So the heat comes from underground, so the hot core of the earth provides the heat when they're buried deep underground, and the pressure comes from the weight of all the crust and the layers above. So that intense heat and pressure can cause the rock to change from one type of rock to another type of rock. And those rocks can be very, very different to each other. So this is an example of a type of marble that's out the back of Tyers. And that forms from a very soft rock called limestone normally. And in fact, you can still see in this the remnants of some old coral. So those, see that white with the circle in it? They're the remnants of some old limestone, so some old coral that was in this rock, but it's now mineralized into a different mineral, and it's very, very hard. That's the other thing about metamorphic rocks, because basically they've been super cooked, so they're very, very hard. Another very common metamorphic rock is this slate, which is very common on floors, not so much in houses now, but certainly when this house was built, it was very popular because it's quite hard wearing and people liked the look of natural stone. So you can see the slate has layers in it, or you can see where the layers would be in it, and so they kind of flake off the top this way, which is why they can split it into tiles. So it's not layers like sedimentary rock, it's layers that form from when it is squashed by so much pressure and it gets so flat at the same time that it is being cooked, if you like. Also, the rock that it forms from may be, or in the case of slate, is indeed a sedimentary rock. So those layers are already there, and then it gets kind of cooked into hard layers.